Okay, now we've had a little bit of physical motivation that will help us to design sounds that are a little more interesting than pure tones, and which hopefully match things like plucked strings. So one of the things we saw about plucked strings, which actually also applies to resonant cavities, is that they have a bass frequency. So I'll call it F naught, which is supported by, or which is whose frequency is determined by the string length and some physical parameters about the string, like its thickness and material properties. Okay, but also they support a series of harmonics or overtones, which are each in integer multiples of F naught. In fact, non-integer multiples will die out quickly. Okay. We also saw when a string is plucked, many of these harmonics are activated. And they all die out over time, but the higher frequency ones die out more quickly. Okay. So let's see if we can write some code to make something like that happen. So let's choose a bass frequency, which we're quite familiar with. It's concert A. We'll make a sample rate of 44,100. Now let's take 2 seconds of audio. So we'll say sample rate times 2 of the sample rate. And okay, so I'll start there. Now I also need to understand how am I going to make these decay. So, well, actually, first before I do that, let me just add together the bass frequency and some of the overtones. So I'll say y is equal to np.zeros like t. That's a nifty little command in NumPy that makes an array of zeros that has the same length and same type as another array. And then I'll say y plus equals np.cosine 2 pi. We'll say the bass frequency times t. So this is the bass frequency. Let's then add on the first harmonic. So that's called the first harmonic. That would be 2 times the bass frequency. And then 3 times the bass frequency would we refer to as the second harmonic. 4 times the bass frequency we refer to as the third harmonic. And let me add just 3 more. Okay, so I'll do 5 times the bass frequency, 6 times the bass frequency, 7 times the bass frequency. So we got our third, fourth, fifth, fifth and sixth harmonics. Okay, so let's just listen to this first. Okay, so what does that sound like? Okay, so, and let me dial back 1 harmonic at a time and we'll hear the difference. So it's losing some of its color or grittiness. And eventually we get back down to the pure tone, which is a lot less interesting than the other ones. Now the thing is though that this doesn't really sound like a string. So that's because I haven't done everything. I mean, I have done the first 2. So I support some bass frequency, and I've just chosen it here saying that the string happened to be tuned to 440. And I've got the harmonics and overtones, but I don't have things dying out over time. So one thing I can do is make each harmonic exponentially decay. So let me define a parallel array called decay. I'll say that that's going to be e to the negative t. So let's just look at what that looks like. Okay, so it starts off, let me plot that as a function of t. So it starts off as 1, and then it falls off, and it gets much smaller. Okay. So let me just multiply each one of these by decay. All right, so I don't have to keep typing this. Let me copy paste here. So decay, 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 decay. So let's see. Is this going to sound more like a string? So here's what we had before, and here's what the decay. I mean, not really. I mean, I can hear it's decaying. Let me see. Maybe I'll make it decay a little faster. So let me say e to the negative 2t. Okay, so now you can see it decays faster. So what about this? So a little more, but we're still missing something here. So the higher frequency is supposed to decay more quickly. So watch this. If I do so, I'll make the second one decay squared, and then the third one decay cubed. Okay, so this blue line is how quick the base frequency is going to decay. Orange is the first harmonic, and green is the second harmonic. So how about we raise the decay to the power of what frequency it is. So 2 times the base frequency is going to be times decay raised to the second power, and so on and so forth. So let's see if this works a little better. Okay, just one more. So decay to the 7th. Okay, so here's what we had before. Here's what we have now. Okay, that's starting to sound a lot more like a string. You can really hear the pluck now at the beginning, where all the high frequency stuff is there, but the high frequency, it dies off, and so that's where you hear the kind of thing. Okay, so that's starting to sound a lot more like a string. So this is our physically motivated example here. All right, so I'm going to have you do this in the next exercise. I mean, we could keep going and see if we can make it sound even more like a string with more harmonics. This is starting to get kind of repetitive, right? This is something that should easily be able to be factored into a loop. So just real quick to remind you how loops work in Python, or maybe to teach you if this is the first time you've seen it. That's totally fine. So there's a few different kind of for loops. Those are the main loops that we'll need in this course. Let me just show you the most basic one here. So let's say I had an array maybe with 20 random elements in it. And so I can say for I in range length of x, print x at index I. So there's a basic for loop there. So I in range, that's going to loop, that's going to cycle I through 0, 1, 2, 3 up to, but not including this number. So the same as array indices. I could actually, so let me actually print the index I'm at here just to show you. So index 0 is that element, index 1. I'm going to actually use a seed so that this is repeatable. So I'll get the same random numbers each time, so not truly random, but pseudo-random. Okay, range acts like a slice, so you can actually say I'm going to start at a certain place and end. So there's a way of doing that. So now I'm starting at 5 and ending at 19. I could also hop increments. So I could say I want to hop in increments of 3. Now it goes 5 plus 3, 18, 11, 14. Okay, so that's the way you loop. But in the next exercise, I want you just to do a sequential loop. All right, and then we'll talk more in class on Wednesday.